Hi. I'm going to explain you about the different tool directions, tool access definitions, and how it would benefit in creating smooth toolpaths. So we have as you see on the screen, we have a part. So it's a simple three-axis die. So generally what we used to do is we used to run toolpath, vertical three-axis toolpath. So I have created a vertical three-axis toolpath, and if I do a simulation now with the machine tool on, I'll just play. You can see only the X, Y, and Z axis motions involved in doing the cutting. This is a general three-axis toolpath. So the here our concern will be the tool length. So as the die depth is more, we have to have a longer tool overhang to complete the die, and which will create chatter marks. So if we have the feasibility of 5-axis machine in our shop floor, then we could use the 5-axis rotary motions to to control the length of the tool. So we can have a shorter tool length, and we can complete the entire die. So how we can uh, create 5-axis toolpaths for these kind of dies? So here generally what we used to do is we used to have a toolpath. Say for example, I'm going to do settings. So here you can see it's a constant Z 3-axis finishing toolpath, but the uh, the tool axis condition I have not set as vertical, which was the case of the previous toolpath option, but now I have kept generally we used to select lead and lean. So I need a lean angle of 30° in the mode of vertical, and I have created the toolpath. So if I simulate this toolpath, you can see I'll just reduce the speed further. So you can see the B is fixed to the 30° tilt, and then you can see the C axis alone rotating. But here what happens, you can see the to and fro motion of C axis. So if we want to control this one, or that is if you the other way around, we can do this toolpath is instead of going to the uh, lead and leans setting, I can use the tool axis in vertical direction, but we have the option of elevation angle, fixed angle. I can set elevation angle of 60° to attain the 30° of B axis rotation. So with this condition, if I simulate the tool path, you can still find the B axis as fixed to the same angle as earlier, and then we are seeing the similar toolpath where C axis is rotating to and fro to complete the die. But in these two cases, the options of tool axis are different, but the end result is same. And generally, this kind of to and fro motion of C axis cutting is not recommended because of the surface finish quality that we need. So the other way, other tool axis options that we can use to have a smooth rotary motions is by, in tool axis I have defined as towards a point option, and since it is a punch, I have set the tool axis as towards a point option. You can see different options over here, and generally we can say towards a point is the best option to set for this kind of punch, where here you can see I have set the point at minus 50 mm in Z from the base of the table, and I am creating the tool path. And you can see, if I simulate the tool path, you can see, so it's a more we can see a more smooth motion of rotary tables, but simultaneously both the rotary angles are involved. Both B and C axes are involved in this case. So if we want to avoid this kind of both the rotary motions together, and if we want to stick to only one rotary motions, then we can combine this tool axis to achieve that one. So I will explain you that how we can do it. So in the next tool path, what I have done is, in the tool axis, you can still see the tool axis is towards a point, and the point is fixed at minus 50 in Z axis from the face of the table, and also a combination of fixed angle. So I have set the fixed angle elevation at 60 degree. So with these two combinations, when I create the tool path in tool axis, we'll see the, let's see the simulation, how it affects or how it gives a very smooth tool motion. So let's play now. You can see now the B is fixed to that 30-degree angle, and you can see a constant C-axis motion, rotary motion. So this gives a better control and better surface finish on the die. So these are, so this way, with a combination, we can achieve what generally required in the market when we do these kind of die machining in a 5-axis machine. Thank you.